So, question 1a, using a calculator or otherwise. So, it's totally up to you whether you want to use a calculator or not. Let's do the long working. So, 2 1/4, convert, so we work this part first. So, 2 1/4, 4 times 2, 8, 8 and 1, 9, so that's 9/4, minus 5 ones, 5, plus 3, that's 8/5. And all of this, we're dividing by 3, right? So, subtracting fractions, so we need a LCM, a common denominator, which would be 20. Alright, so we can make this 20. 4 into 25, 5 nines, that's what, 5 nines, 45. 5 into 20, that's 4. 4 times 8, that's 32. And that would divide 3/1, so it's times 1/3, right? So we end up with 45 minus 32, that's what, 13. So we're 13/20 times 1/3. Now multiplying two fractions, numerator times numerator, we get 13, and denominator times denominator, 20 times 3, we get 60. So our answer is 13/60. The other problem we can enter that straight into our calculator, 2.14 times sine 75. That would be, to 2 decimal places, that would be 2.07 to 2 decimal places. So next problem, Irma's take-home pay is $4,320 per fortnight. That's every 2 weeks. And each fortnight, her pay is total pay is $4,320. And we are asked for Irma's annual take-home pay. Of course, she gets $4,320 every 2 weeks or every fortnight. And how many fortnights are in a year? So a year has 52 weeks. That would be what, 26 fortnights. So her annual pay, would be $4,320 times, how much time would she have received this amount? 26 times. Because there are 26 fortnights in a year. Hence, her annual take home would be 26 times 320. Let's write that out. 26 times 4,320. And that's $112,000. $112,320. Dollars, of course. Okay. Next, we're asked to determine the amount of money that Irma allocates for rent each month. So the amount she allocates for rent each month, that's X. And so we can form an equation. So for rent, that's X, right? So to solve for X, mean the total of all these values must be equal to 4,320. So X plus 629 plus 2X plus 1750. All of this must be equal to 4,320. So we can add all the X terms, group all the X terms. We have X and we have 2X, that's 3X. And if we group all the constants, we have 629 plus 1750. And then we can subtract 2379 from both sides, so we end up with 3X equal to 1,941. And to get the value of X, we divide both sides by 3. Divide both sides by 3, we'll end up with 1,941 divided by 3. That's 647. So the amount that Irma allocates for rent each month is $647. Just a slight correction here. This 647 is the amount that she allocates to rent per fortnight, per 2 weeks. So per month, amount allocates to rent, amount to rent per month. So the amount per fortnight is the value of X here, 647. So per month, we just double this value, 2 times 647. And what do we get now? 12. Double 47, we get what? 94. So the amount to rent per month would be $1,294. And we get that value by multiplying the fortnightly amount times 2. 647 would be paid 2 times per month. Now we are told that all of Irma's earning is used to pay her son's tuition costs, which is $150,000. And if Irma's pay remains the same and she saves the same amount each month, what is the minimum number of years that she must work in order to save enough money to cover her son's tuition costs? Now, recall from the table that Irma saves $1,750 per month. Per fortnight, sorry. Which is every 2 weeks. And which means she saved $1,750 per fortnight. And remember, we're told that there are 26 fortnights in a year. So per year, she saves 26 times, remember, 52 weeks in a year. So we have 26 fortnights in the year. And she saved $1,750 per fortnight. So per year, she saves 26 times 1750, which gives what's 26 times 1750? That's $45,500. This is per year. Now remember, she's saving for her son's tuition, which is $150,000. Right, so minimum number of years. In other words, how long will it take, if she saves $45,500 per year, how long will it take her to save $150,000? We can just simply divide the amount she needs to save, divide by the amount she's saving currently per year, and we end up with 3.3 rounded to 1 decimal point. But remember, so she will work a little over 3 years. So the minimum amount of years would be 4 years. Alright? Because you want near, so 4 years. Alright, which is equal to 4 years minimum for her to save this amount. Because it will be just over 3 years and a few months. So minimum amount of years would be 4. And the reason for this, after 3 years, she wouldn't reach $150,000. It would take her more than 3 years, because if you multiply 3 times 45,500, you'll get a value that's below the 150. Alright, so when she reaches the 4-year mark, she will have gone above the 150. And she would be able to pay her son's tuition cost. Next problem, simplify this expression. So multiply constants, 3 times 4, that's 12. And then p squared times p to the power of 5. Law of indices, we add the 2 powers since it's same base p. So we add the powers 2 plus 5, that's 7. Next, we're dividing, so we have 3x over 4y cubed. We can multiplication times, and then we invert 20 over y squared over 21 x squared, and we can divide. So let's bring everything together. So 3x times, so the 3 times the 20 give us 60, and x times y squared, that's xy squared, and this is over 4 times 21. Remember, you're multiplying fractions numerator times numerator. And of course, denominator times denominator. 4 times 21. That's 84. And then that's y cubed. And then we have x squared. Now let's try and reduce. So we think of a number that can divide into both 60 and 84. Of course, 12 can go into both numbers. We can divide both numbers by 12. 12 into 60, I think that's 5. 12 into 84, that's what, 7. So here we have 5 over 7. Let's see if we can reduce. So x, this one of is x into x squared here. So we're left with the x down here. And then we can divide both by y squared. So we divide by y squared, we get 1. And if we divide this by y squared, we're still left with a y down here. So the denominator would be 7xy. So 5 over 7xy would be our solution. So here we have another problem. So we have several approaches we could use. Notice the first objective here is to get rid of the denominator. So we can times each term. We can times each term by the LCM, which would be the product of the two denominators, 7x minus 1 times x. So let's times each term by 7x minus 1 times x. So 7x minus 1 times x. We multiply this to 3 over 7x minus 1. Plus, I will multiply this also to 1 over x. And you multiply to the right hand side also. But remember, anything times 0 is 0. So the right hand side will become 0 naturally. Alright? So 7x minus 1 times x times 0 would give us 0. Now, you see what happens? This 7x minus 1 into this. So we're left with x3, 3x. Plus this x into this x. Left with 1 down here. So we are left with 1 times 7x minus 1. Or 7x minus 1 times 1, which is 7x minus 1. Equal to 0. And of course, a group like terms. So the 3x and the 7x, that's 10x. It's minus 1, we can group over here, that's positive 1, right? Divide both sides by 10. So x equal 1 over 10. Or 0.1. Next, when a number x is multiplied by 2, so of course, multiply by 2, that's 2x. The result is squared. So we square this result to give a new number y. So that's a new number y. So if we square both sides, we can leave the answer like that. Or if you square both terms in the bracket, square the 2, you get 4. Square the x, you get x squared. Which is equal to y. Determine the two values of x that satisfy the equation y equal to x and the equation deriving C1 above, which was y equal to 4x squared. Of course, y equal, we can use substitution, of course. So y equal x, let me call this equation 1. And y equal x, 4x squared, let me call this equation 2. Of course, we can substitute one into the other. Now, since y is equal to 4x squared, then we can say, we can substitute y equal x into y equal 4x squared, and you'll end up with y equal to 4. Now remember, x and y are the same. X equal to y. So x I can replace with y. So y equal to 4y squared. And of course, we have a quadratic here, so I can group everything on one side. Let me group everything over here. So I have y minus 4y squared is equal to 0. And of course, I can factorize y. So I have y. Remember, y is 1y, so I would have 1 minus 4y, of course. So we factorize that. Equal to 0. Notice when you expand the bracket, you get the original expression that we have above here. Y times 1, that's y, 1y. And y times 4y, that's 4y squared. solving by factorization, we can equate both brackets to 0. Remember, y times y minus 1 minus 4y equal to 0. So which means that y is equal to 0, or 1 minus 4y is equal to 0. For solve this equation, 1 equal to 4y, divide both sides by 4, divide both sides by 4, then y is a quarter. And of course, we can use this to get the x values. Remember, y is equal to x. Alright? So if y is 0, x is also 0. And if y is a quarter, here, x is also a quarter. That's our solution. Alright, so when y is 0, x is 0. And when y is a quarter, x is a quarter, since y is equal to x. Another approach you could have taken is the elimination method. If I were to use the elimination method, I would subtract. So I have y equal x, and I remember I have y equal to 4x squared. And if I subtract, term above take away term below, y minus y, that's 0. And subtract, term above take away term below, I would end up with x minus 4x squared. And that way my x is 1x, and of course you could factorize. X is a common factor, so x, and I'll have 1 minus 4x in the bracket. And of course you equate both brackets to 0. So equate x to 0, and equate the other bracket, which is 1 minus 4x to 0. 1 minus 4x equals 0. And if you solve this, you'll get x equal to, you have 1 equal to 4x, which means x equal to a quarter. Divide both sides by 4, x equal to a quarter. And in the same way to get your y values, when x equals 0, if I substitute when x equals 0, then y equals x, y is also y is 0. And when x equal to a quarter, of course, y is equal to a quarter. So you end up with the same solutions. By the way, over here I have a correction of y equal to a quarter. I have x and x, y equal to x, so x is also a quarter. So use a ruler and a pair of compasses, construct triangle NLM, within which LM, and of course, let me just demonstrate how you would sketch this triangle. So LM, draw a straight line, of course. Of course, and you measure from 0 to 12 on your ruler. From 0 to 12, I'm just doing a sketch here. LM, so L, M, and you ensure that the length is 12 centimeters. Alright? Of course, you measure from 0, so 0 to 12 on your ruler and a pencil. Angle M is 90, and angle L, so the angle is the middle letter here, so angle L should be 30, so you construct a 30 degrees here. And angle M should be 90 degrees. Let me just construct a 90 degrees first. So you put your compass needle on the M. So compass needle on the M. And you swing an arc. Swing a semicircle. Alright. Several ways to do this. What you could do. And of course, you put your compass needle here. You swing an arc. Put the compass needle here. You swing another arc. Put your compass needle here. You swing an arc. Put the compass needle here, you swing another arc, and if you connect, using your ruler and your pencil, and you draw a line through, this will be 90 degrees, to be a right angle. And then, angle L is 30 degrees, and how do you get the 30 degrees? So you put your compass needle on the L, you swing an arc, you can make it a semicircular arc, and where the arc meets the line, you swing another arc there. And just to know, this angle, if you should connect a line from L through this line, this angle will be 60 degrees. This angle will be 60 degrees if I should draw a line from the L to the intersection here. But you do not want 60 degrees. What you want is 30, which means you need to bisect. You need to bisect the 60 degrees to get the 30. So to bisect the angle, here, compass needle here, you swing an arc. Compass needle here, you swing another arc. And you draw a line from the L through the intersection, and of course all these lines should be straight, And of course, where this line here meets this 90 degree here, that would be at the end. That would be the triangle completed. So that's your triangle LM. And of course, this angle, if you measure this angle, will be 30 degrees. Right, half of 60. And of course, that would be your triangle. So here we have a triangle ABC with vertices 1, 1, that's A. So A is a 1, 1, 1 on the X, 1 up. B is 1, 4. And C is 3, 1, as shown in the diagram below. Now we are asked to, we are told that the triangle ABC is mapped onto triangle element by a reflection in the x-axis followed by a reflection in the y-axis. On the diagram, draw and label triangle element. So in other words, for us to get the triangle element, we have to reflect ABC in the x-axis. Reflect it in the x-axis, followed by a reflection in the y-axis. And that's how we'll get element. So let's do that now. Let's reflect ABC in the x-axis first. So here's x-axis. So the x-axis will behave as a mirror line. So notice we have A, and how far is A from the mirror line here? The x-axis is 1 unit away. So the image will be here. 1 unit on the other side. C, same. 1 unit away on the other side. And how far is B away? Is 4. So it will be negative 4 down here, right? Alright, so we'll reflect this. So this is the first reflection in the x-axis. Alright, and we are told, followed by a reflection in the y-axis. So now the y-axis will behave as a mirror line, which means that the distance of this image, of this point here, from the y-axis will be the same over here. So, alright, so this was ABC to element. Alright, so A, so this would be A, and then this point, same distance away from the y-axis. And then this point, which was the image of C, how far is that away? 3 units, so it would 3 units away over the other side here. Alright, so I can call this L, M, N, alright? So this would be the triangle, reflecting ABC in the x-axis, followed by reflection on the y-axis. Notice the coordinates. Let me write the coordinates. Coordinate L. L is which coordinate? L, this point is what? Minus 1, minus 1. M. What are the coordinates of M? Minus 1, minus 4. And N, what are the coordinates of N? Minus 3, minus 1. Next, we're asked to describe the transformation that directly maps ABC to element, and you can see if I should draw a line from the origin to A, which is, and then from the origin to L, you see that's a 180 degrees rotation. So in the description, likewise, if I draw a line from the origin to C, and then from the origin to the corresponding point to N, of course, it's a 180 degrees. Which means the transformation would be a 180 degrees rotation about the origin, and the origin is 0, 0. Good? And it doesn't matter if it's clockwise or anti-clockwise, you still end up at the same place. If you're located here and you're to rotate this pointer 180 degrees to this clockwise, then you'll end up here. And likewise, if you rotate anti-clockwise, you will end up same place. So the direction doesn't matter. It's alright, direction doesn't matter. The matrix, of course, so we do the unit 1, remember, go about it. So if we call this 1, call this 1, and it's a unit matrix 1, 0, 0, 1. if you should rotate this unit, the 1, 0, 180 degrees, it will end up here at the point 0, -1. And if you should rotate 0, 1, sorry, I made an error here. If you should rotate 1, 0, let me just correct this. So you rotate 1, 0 first. 1, 0 is this point. You'll end up where? Here, 180 degrees rotation. That would point will be -1, 0. And if you should rotate 0, 1, which is this point here, you'll end up at the point 0, -1. Alright, so this is the transformation matrix that represents a 180 degrees rotation about the origin. And if you should multiply this matrix by any of the points in A, you will get element, the corresponding element points. So P varies inversely as the square of V. So P varies inversely. So P is equal to inversely to the square of V. So K over the square of V, which is V squared. So that's the equation we'll use. We'll form there. So we are told that V equal to 3 when P equal to 4. So when we remember K, P equal to K over V squared. So we substitute. So P is 4. K, we are told that V is 3. V is 3, so V squared, that's 3 squared will be 9. So I can just multiply both sides by 9. I end up with K equal to 4 times 9, which is 36. And then we're asked now to find the value of V when P is equal to 1. So again, recall that P is K over V squared, but now we know the value of K is 36. So 36 over V squared. Alright, we're asked to find the value of V when P is 1. So when P is 1, replace P with 1. We have 36 over V squared. And we can times both sides by V squared. So 1 times V squared. And V squared. 1 equal 36. Which means V is the square root of 36. But not we're asked for the positive value of V, which will be 6. The equation of a straight line is given as x over 3 plus y over 7 is equal to 1. This line crosses the y-axis at Q, determining the coordinates of Q. Now remember that graph cuts y-axis. So graph cuts y-axis when x is equal to 0. So we sub x equals 0 into this equation here. So we'll have 0 over 3, which is just 0. So all we'll have left is y over 7 is equal to 1. You multiply both sides by 7, of course. So y is equal to 7. So the coordinates of Q would be 0, 7. Alright, remember, so if you have a graph, let's do a pictorial representation here. If you have a graph, if this is the y-axis, if it cuts the y-axis at 7, then what are the coordinates of this point? 0, 7. Next we're asked for the gradient of the line. Now remember, the gradient of the line, if we have the equation, is a coefficient of the x when y is the subject. So what we can do is multiply each term by the LCM here to 21, just to transpose for y. So multiply each term here by 21, and 21 times each term. So 21, so 3 into 21, that's 7, so this will be 7x plus 7 into 21, that's 3. So 3y, sorry, is equal to 21. So we can transpose for y. So we end up with 3y equal 21 minus 7x. Divide both sides by 3. So 3 into 3, 1. So y is equal to that. Remember the gradient. Now y is the subject of the formula. So the gradient is a coefficient of the x. Alright. So the gradient of this line m is negative 7 over 3. So we have a cumulative frequency distribution table there, and we are asked for the class 21 to 30. We're asked for the lower class boundary, so this is 21 to 30. So of course we subtract 0.5 from the lower value, we get 20.5. And if you're asked for the upper boundary, you add 0.5 to these values, to 30.5. But we're asked for the lower boundary, which would be the lower class boundary, which would be 20.5. We are also asked for the class width, which is the upper minus the lower boundary. I can use any one of them here. The upper is 30.5. The lower is 20.5. So the class width would be 10. So next we are asked how many vehicles were recorded in the class 31 to 40. Let's go back to the table. Now it's very important to remember that this is a cumulative frequency table. So if you want the actual frequencies, you will have to do some subtraction. If you want the actual frequencies. Alright, so of course the first frequency is the same as the first cumulative frequency value, which is 24. And of course, you get the frequencies, you'll subtract. So the difference between 24 and 59, that's what, 35? Difference between 59 and 101, what's that, 42? Difference between 101 and 129, that's what, 28? And difference between 129 and 150, that's 21. So these would have been the frequency. Now we are asked for the number of vehicles in the class with 31 to 40. So the answer to this question would be 42. So this would be 42 vehicles, right? Next question. A vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5? So more than 50.5, at least, I'll use this one obviously. So more than 50.5, that's 21 vehicles. So the probability, in answering this question, the probability will be 21 over the total. So 21 over 150. Over 150. Of course, you can reduce it. You can divide by 3. Divide by 3, you get 7 over 50. Alright, either of those values. These fractions are equivalent, so either of these can work. Next, Byron estimates the median amount of petrol to be 43.5 liters. Explain why Byron's estimate is incorrect. So he's estimating that his median would fall into this interval here, which is impossible. Because if you look at the frequency from up to 40 liters, we have gone more than half. Notice the total was 150. Median is supposed to be the middle value, right? So we are past the middle value long ago. Because 101, the cumulative frequency here, alright, is way more than half of 150. So the median could not have been in this interval here, 41 to 50. And as a matter of fact, the median would have to be in this interval, somewhere between 31 and 40. So next we are required to do a histogram. And of course, for the histogram to be done, we need the class boundaries. So for the 11, so we subtract 0.5 from the lower values, add 0.5 to the upper values, and we'll do it for all the rows, 30.5, 40.5, 40.5, and remember, the histogram resembles a bar graph, except the bars are connected. And of course, when you're doing the histogram, so we'll put the volume or the class boundaries versus the frequency, very importantly. So we're doing the class boundaries here versus the frequency. And that's how our histogram is drawn. So let us go to the graph paper now and do our histogram from this table. So of course, the frequencies was here, and the volume. Alright. Now the volume goes up to 60.5. A suitable scale would be 10, 20, 30. So the kind of number every 2 to 10. So 10, 20, 30, 40, 50. And notice with this type of scale, 2 to 1, a 2 to 1 scale, every two thin lines, well, each thin line value 1 for both axes. Alright, so the volume we have 10.5 and 20.5 going up to a frequency of 10 of 24. So 10.5 is midway between 10 and 11. Alright, and 20.5 midway between 20 and 21. Alright, so I do a table here. So 10.5, and by the way, these lines are supposed to be straight. These are supposed to be straight lines. So 24, where is 24? 24 is 4 above the 20. So 10.5, and also at 20.5 up to 24. And of course, you use a ruler and you connect a bar, so this should be a straight line. So if I give it bend, I'm just demonstrating for you. So you will do this on your own. Alright. And you have your bar, you connect your bar, right? At 24. Height of the bar will be 24. Next one, the height of the bar will be 35. That's the frequency. 35. 35 is midway between 30 and 40, right? So we extend this up to 35. And of course, and 30.5 also up to the same height, 35. Alright. And it's supposed to be a straight line, of course. Next one, the height is 42. The frequency, remember the frequencies we use as the height of the bars. So 42. And this of course is 40.5. So this will extend up to 42. 42 will be 2 thin lines above the 40, right? And then at 40.5. 40.5 is just above the 40, right? Up to the same height. So all the bars, so 2 bars up to the same height all the time. The close a bar. Next one. The height is what? 28, and the next one is 21. So 50.5 up to 28. 28 is where now? 28 this will be 25. So 28. So 28 will be 3 above this, right? 28 will be 1, 2, 3 above it, somewhere there, approximately, and then to 50.5. And the final one, the height is 21. 21 is also 1 above the 20, 60.5. So 21 is also 1 above the 20, right? It should be here. And the x value is 60.5. That's the value. And of course, all your lines are meant to be straight and neat, and should look way more attractive than mine is. The scale on a map is 1 to 25,000, which means that every centimeter that you see on the map, the actual distance, or the real distance, is 25,000 centimeters. Which means that for point, so this is a map, and this is actual or real distance. So every centimeter on the map. So if 2 centimeters on the map will be 50,000 centimeters in reality, and so on. Alright, so half of centimeter on the map, so half of centimeter on the map. So it's ratios, so you just take half of the 25, alright, which is 12,500 centimeters. But note you're asked to convert the distance, the actual distance, in kilometers. So you have to convert this into kilometers. So the actual is 12,500. So how many centimeters make a kilometers? 100,000, right? Alright, so 100,000 centimeters is a kilometer. And that's how we convert it. So we're converting 12,500 centimeters to kilometers. And that would give us what now? 12,500 divided by 100,000. 0.125 kilometers. Another approach you could have taken is to say, okay, a centimeter on the map is 25,000 centimeters in reality, which means a centimeter on the map is the same thing as divide 25,000 by 100,000 is the same thing as 0.25 kilometer. In other words, whenever you say 1 centimeter on the map, the actual distance is 0.25 kilometers. 2 centimeters, the actual distance is 0.5 kilometers. And so on. Alright? So which means half of a centimeter. Just divide both of these by 2, since you want half of a centimeter. You divide this by 2 also, and 0.25 divided by 2 is 0.125. So the approach you could have taken. So let me just rewrite the scale in kilometer this time. So on map, a centimeter, and the actual on map, a centimeter is, we said what, 25,000 centimeter, which is, we said was 0.25 kilometers. So we're asked for 2.25, the actual area in km square for 2.25. So you want the actual area, we can square both sides, so square the 1 centimeter. So you get 1 square equal 1 cm square, or 1 square centimeter. We square the 0.25, 0.25 square, that's 0.0625 km square. So we square both sides. Now we want 2.25. So we times both sides by 2.25. So 2.25 times the left and 2.25 times the right. So 2.25 times 0.0625 is 0.00390625. I use everything on the calculator, and that's km squared. So this was the scale, the original scale we were given, and to get this you square both sides. And to get this we times both sides by 2.25. So hence we have 2.25 cm square is equivalent to 0.00390625 km square. So this would be your solution. So the diagram below, not drawn to scale, shows a cross section of 2 cylindrical jars, X and Y, as we can see below there. So now here are our jars, and we're told that we're also find the volume of water in jar X. Now remember, the jars, they are cylinders. So the volume of a cylinder is pi r square h. Good. So pi r. Now we are told the diameter. We are told the diameter for jar X is 3D. So r would be half of that. So r for jar X would be 3D over 2, and r for jar Y would be just d over 2. Remember, r is half of the diameter, right? Half of the diameter. Alright, so pi and r we're using 3D over 2. That's r, and we square r, right? And the height of the water in the tank, that's 4. So we can simplify this. Yeah, so in simplifying, we have pi, we square this, square the 3, we get 9 d square over 2 squared, that's 4. And now we have our 4 here. Square that, then we have our 4 there. So 4 into 4, that's 1. So the volume is pi times 9d squared. So we can write that as 9 pi d squared. And it's centimeters, right? So cubic centimeters. So now if all the water from jar X is now poured into jar Y, calculate the height the water will reach. Alright, so in jar X, again and this is for jar X specifically. Again, jar X is a cylinder, so again the volume is pi r squared H, and the volume of the water will be the same as what was on jar. So sorry, this is specifically for jar Y, because jar Y is also a cylinder, right? So the volume is the same as the same amount of water was in jar X, which was 9 pi d squared. And then the volume of water in jar, the volume here will be pi. The diameter in jar Y, that's r. R was d over 2, right? R half d. So jar Y, so r squared will be d over 2 r squared. And the height, that's what we're trying to find, right? We do not know. So simplifying, we have 9 pi d squared equal to pi. And we square this term, we'll get d squared over 4. And of course we have put back our height. So now we can multiply both sides by 4. So we're transposing for h, right? Both sides by 4. So this 4 into this 4. So we're left with pi d squared h. And then 4 times 9, that's 36. So 36 pi d squared. So we're transposing for h. So we divide both sides by pi d squared. Pi d squared into itself, that's 1, so h, and pi d squared into itself, also 1, so h equal to 36, so 36. So the water from jar X would reach a height of 36 centimeters in jar Y.